Sets and probability set notation. A set is a well-defined collection of objects denoted with a capital letter. Each member of a set is called an element. The elements are listed in braces or curly brackets. For example, the set A, note how that's denoted with a capital letter, contains the elements 1, 3, 5, 7 and so on. Note the curly brackets. A set may be defined in a property like the set of odd numbers, which is written formally as A consists of elements x such that x is a counting number not divisible by 2, and that defines all odd numbers. So we'd read that as the set A with elements such that x is a counting number not divisible by 2, exactly as it says here. So it's the colon here that is the such that. The universal set is a fixed set of all the elements under consideration in a particular problem. So in a certain situation, A, the odd numbers, might be the universal set, or it could be a much smaller set, just like the numbers 1, 2, 3 or 4. It's whatever we're considering at the time. The letter U is used to represent the universal set. A set with no elements is known as a null set or as the empty set. It is shown either with braces showing nothing in between, or this symbol here, which is actually the Danish letter so just a circle with a line through it. The symbol shown here means is a member of, or is an element of, or if you like, belongs to. For example, 11 belongs to the set A that we defined over here. A Venn diagram shows sets as circles with elements common to sets shown in the overlapping of the circles. So when we say elements common to sets, so we may have more than one set, and if there's numbers that's in both sets, then we put them in the overlap. The circles are inside a rectangle which represents the universal set. So the universal set is represented by a bounding rectangle, and other sets are shown as circles within that rectangle. Sometimes the elements are listed in the circles, and often the numbers of elements are shown in the circles. So we could draw a Venn diagram either way, and we'll look at that in a second. So for example, if the universal set is just the numbers 1 to 6, so this might be a problem with a standard fair cubical die, which normally shows the numbers 1 to 6. The set E is 2, 4 and 6, so that seems to be the even numbers from this set, and P is 2, 3, 5, so that's the prime numbers from this set. Then if we look at this Venn diagram here, 2 is common to both E and P, so it's in the overlap. The other elements of E, 4 and 6 are shown here, so they're inside of E but not inside of P. 3 and 5 are shown inside P but not inside of E, and 1 didn't belong to any of them, so it's here. It has to be within the bounding rectangle. This one shows in terms of the number of elements in each part of the diagram. Note this 3 here means there's 3 in the E circle. Then we have 2, which would be the 4 and the 6. There's 1 element in the overlap. This 2 here would represent the 3 and the 5, so 2 elements there. 3 elements in all in here. The 1 is outside here, but that's not 1. That's telling us there's 1 element outside. And the 6 up here in this rectangle tells us there's 6 elements in total in the set. And we know that's the case. We've got 1, 2, 3, 4, 5, 6. So these are two different views of the same information which we've just been discussing. The left-hand diagram shows the actual elements of each set or region of the Venn diagram, whereas the right-hand diagram shows the number of elements in each set or region. Mutually exclusive sets have no elements in common. They are also referred to as disjoint sets, and you need to be aware of the terminology here. You need to know what a question is saying to you. A Venn diagram containing disjoint sets would appear as below, and we can see there's no overlap if the sets are disjoint because there's no common element like we had the two here. A subset is a set that has all of its elements also belonging to another set. If A is contained in B, then all of the elements in set A are also in set B. So note we've got a new symbol here, contained in. So that would be this situation. The set A is contained in B. The intersection of two sets refers to the common elements from both sets. It's denoted by A intersection B. Most people refer to it as A and B. So that would have been the 2 in this example over here. So in general, it's this bit here. The union of sets A and B, written as A union B, is the set of elements that are in sets A or B without repeats. So not A and B, but A or B. So that's this here, but make sure when it says without repeats that we don't count this bit twice. The complement of set A, written as A dashed or A bar, is the set consisting of all elements that are not in set A. The diagram on the left below shows the set A shaded. The diagram on the right shows the set A bar shaded. So here we have A, and there we have not A.